Hi, I am Muhammad and you are on ASCE7 University YouTube channel. As you know, in Chapter 1 we are talking about the basic definitions and requirements of ASCE 722. For today and of course the third session, I have prepared some special points about load's importance factor and also its effect in the design of the buildings. Please subscribe to my channel and visit my Instagram and Telegram pages for more contents. Before talking about the main objective of this session, let me have a review of the previous session. According to Table 1.5-1 of ASCE, we found that there are four main risk categories for different kinds of buildings according to their occupancy and use. Each of them has its own characteristics, and I tried to give you some examples to clarify their borders. Moreover, we referred to Table 1604-5 of International Building Code IBC 2021 to access more details and examples for different buildings and structures risk categories. And finally, we observed that maybe the best reference to assign a correct risk category to a specific building is Chapter 3 of IBC, where buildings are divided into 10 groups and subgroups based on their occupancy and use. Before watching the main part of this session, if you have any problem with risk categories concept yet, please check the previous session that I put its link here. Be careful that assigning a risk category to a structure is not only the structural engineer responsibility, but also the architecture and owner shall be involved in determining it. Having enough perception about Table 1.5-1, we can assign importance factors to buildings and structures by using Table 1.5-2 for earthquake loads. As you see, importance factor is a function of risk category and its value range from 1 to 1.5. But what is the main objective of using importance factor in our designs, and what is its effect finally? What is the concept behind these numbers and why do we use them? The numbers 1.25 and 1.5 means that for these kind of risk categories, it is essential to consider higher seismic loads based on which we have in equation 12.8-1 and 12.8-3. Maybe it would be correct to say that the true purpose of using it is to provide an additional strength for risk critical facilities for the same level of ground motion and type of detailing. In other words, the purpose of using this factor is to improve the capability of certain types of buildings, such as essential facilities and structures containing substantial quantities of hazardous materials, to have their serviceability and functionality during and after earthquakes. All in all, when we deal with higher importance factor, we will have higher CS and consequently higher seismic base shear. This means that larger loads are on our structure, which means we need larger members to provide enough resistance forces. Hence, these structures members would remain in elastic deformation zone and won't experience plastic deformations during an earthquake. And finally, the most significant result occurs for these buildings: lower ductility, which leads to lower drifts and damages in such structures. Let me show you how these conclusions are correct with an example. If you refer to fourth row in Table 12.12-1, you would see that according to this table, the maximum allowable drifts in different buildings with different risk categories are limited to specific amounts. I have brought a figure which illustrates the maximum allowable story drift versus relative seismic base shear. As you see, if we deal with a building in risk category 1 or 2, the relative displacement would be twice our building which is in risk category 4 according to what we saw in table 12.12-1. I hope you have found out the importance of importance factor and also its effect on strength and ductility of a structure. I hope you have loved this video. If you did, please subscribe to my channel, like the video and leave me a comment. Don't forget to download the PDF file of this session from my Telegram channel at ASCE7_22. Follow my Instagram page for more contents and come back soon for the beginning of chapter 2, combination loads.